So the ideal gas equation is here. So PV equals nRT. So P is pressure, and that needs to be in pascals. V is volume, and that needs to be in meters cubed. N is the number of moles. R is something called the molar gas constant. Now you'll be given the value of this in an exam, but it's 8.31 joules per Kelvin per mole. And the T is temperature, and that's in Kelvin. So we need to worry about two things here. Firstly, we need to be able to rearrange it. So PV equals nRT. We need to be able to rearrange that to give V is nRT over P, or we can have N equals PV over RT, or we can have T equals PV over NR. You won't be asked to rearrange it for R because that's the gas constant, but if you were, that would be PV over NT. Now, it's very important that when we write this, they're capital, so the N is lowercase, but all the rest are capitals, and that's particularly important for the T, because if you have lowercase t, it would be time. So we need to make sure that it's not lowercase t. Now, the other thing we need to worry about is units. So we need to make sure we get everything in the correct units. So let's do it one at a time. So the pressure, so if I'm giving it in kilopascals, to go to pascals, I times by 1,000. If I'm giving it in megapascals to pascals, I need to times it by 1,000,000. If I'm giving it in atmospheres, then I need to times it by 100,000, because 1 atmosphere is 100,000 pascals. Right, so volume, I can be given the volume in decimeters cubed. So to go from decimeters cubed to meters cubed, I divide by 1,000. If I'm given it in centimeters cubed, I need to divide by 1,000,000. And then temperature, if I'm given it in degrees C, to get to Kelvin, I add 273. Okay, so that's the equation that we need to use. We just need to practice some calculations using this equation. So here's an example question. So it tells me that a sample of 2.18 grams of oxygen gas has a volume of 1,870 centimeters cubed and a pressure of 101 kilopascals. And it wants to know the temperature. So first thing I need to do is rearrange the equation. So PV equals nRT. It's important we show all our work in here. So if I rearrange that to give temperature, the temperature is PV over NR. And then it gives me the volume here. So that volume needs to be converted to meters cubed. So I need to divide that by 1,000. Sorry, not 1,000, by 1,000,000. And because that's in kilopascals, that needs to be times by 1,000. So that's going to give 101,000. It gives me the value of the R, so it's always going to give you that. Now, it doesn't tell me the number of moles, it tells me the mass. So we need to use the equation. Number of moles is mass over MR. And we need to remember that oxygen is O2. So you'll notice that these two answers are a factor of 2 out, and that's because they're trying to trick you that it's that they're assuming that some of you are going to just treat it as just an oxygen atom rather than an oxygen molecule. So when I first saw this question, I knew one of the correct answers would be those, because I knew that they'd be trying to trick you with this diatomic molecule. So we've got to remember that hydrogen, nitrogen, oxygen, and group 7 are all diatomic, which means they come as a molecule. Sorry, I can't spell there. Which means that they come as a molecule of 2 atoms. So if you look in the periodic table, oxygen is 16, so times 2, 16 times 2 is going to be 32. So number of moles is mass over MR, it's going to be 2.18 over 32. So if I put all of this in my equation now, so the pressure is 101 100,000 times by my volume, which is, where's my volume gone? Right, 1870 over a million. And then my N is my 2.18 over 32 times by R, which it gives you in the question, is 8.31. And if you stick all of that in your calculator, you will come out with answer B.